Okay, let's continue programming in OpenGL and let's get our first triangle on the screen. So let's go ahead and run this, and here's where we left off. We have our OpenTK window open and ready to go. It's clearing to the color that we set. I'm going to go back into the code now, and I'm going to actually, let's go ahead and add a couple of functions here. The first one is going to be the OnLoad function. And this function is called one time when the program is starting up or the window is starting up. And then we're going to have another one called the unload. And that's going to be called one time when the program or the application is shutting down. And then I actually want one more. Let's do the on resize. Okay, so anytime the window is resized, this function is going to get called. I'm not really going to be resizing the window, but in case we ever do want to resize it, I'm going to add one function in here from OpenGL, and this is the viewport. And this tells OpenGL what our viewport or the rectangle that we want to draw to looks like. Now this rectangle is just going to be the full size of our window. Okay, so I'm going to start at 0, 0, and the width is just going to be the width of the window after resize, and then the height of the window after resize. Okay, so this will just tell it every time that the viewport is the whole window. What we want to do here is program OpenGL in a modern way. It does take quite a bit more setup to get the triangle, but once you have that, we do have a lot more control over the program itself and what's actually displayed on the screen. So there's two different types of profiles in OpenGL. So OpenGL profile compatibility, or the compatibility profile, is the one that gives you access to all the old functions, including the, I believe you still have access to the fixed function methods and stuff like that. We're not going to be using any of that. We want to do completely modern. And so the other one is the core profile. And the core profile means I only want access to the current functions that are available for modern graphics cards and modern programming. We're going to disregard all of the old stuff, and we're just going to use all the current and new stuff. Okay, so we're going to be programming on the core profile for OpenGL. So let's go ahead and get started. In the onload function, the first thing I want to do is this ClearColor function. I'm going to move that up to our onload function because we only need to set that one time. Once we set the ClearColor, it's going to be the same every time we clear. So let's set it once and be done. Next, let's go ahead and set our vertices. Okay, so we want to draw a triangle, and a triangle has 3 vertices. Okay, so I'm going to define our vertices here, and it's going to be a floating point array. I'm going to call this the vertices. Okay, and inside this array right here, I'm going to define all of our vertices. So the vertices are going to have 3 components. They're going to have an X, a Y, and a Z. So every 3 floating point items in this array is going to be the X, Y, and Z. And before I talk about that, let's go ahead and talk about what the graphics card actually looks like when we're rendering to it. Okay. The coordinate system of the graphics card, if we're going to write to that coordinate system, is called Normalized Device Coordinates. Okay, and it looks like this. So the graphics card at the very top has a +1 on the Y for the max on the Y. It has a -1 on the Y for the minimum. Okay, and on the right is a +1 for the X and a -1 for the X. So anything that is more than +1 is going to be outside the bounds this way. Anything less than -1 is going to be outside the bounds this way. To make this really simple, we're just going to program directly in these normalized device coordinates, so we can just write directly to the graphics card. So all of our vertices are going to be passed through in this coordinate system. And so let's make a triangle that looks something like this. So I'm going to have 1 point here, 1 point here, and then 1 point here. Let's draw some lines in there. All right, so this is what our triangle is going to look like, approximately. Obviously not exactly to scale what I want, but this is going to be 0.5 on the Y, a +0.5, and then 0 on the X. So it'll be a 0 and then a +0.5. Over here, we're going to go to a +0.5 on the X, and then it'll be a -0.5 on the Y. And then down here, we're going to go to a -0.5 on the X, and then a -0.5 on the Y. Okay, so those are going to be our 3 points for our triangle. So let's go ahead and define that in our code. In our vertices array, we're going to define the X, Y, and Z for each vertex. So the first one, let's just start at the top here. So this will be our first one. So we have 0 and 0.5. And then remember, we also want to specify the Z coordinate, and the Z coordinate is just going to be 0. Let's define our next vertex. All right, so this is going to be 0.5 on the X and -0.5 on the Y. Okay, z coordinate is 0. And then finally, this one right here is negative 0.5 on both components x and y. And then again, our z component is 0. Okay, so here's our 3 vertices. I can kind of put some comments in here just to show this. So this is vertex 0. All right, there we go. So now this is defined in our RAM, okay, on the computer, but I actually want to move this to the RAM on the graphics card, or to the, so I want to move all this information to the graphics card itself. And the way we do that is through something called the vertex buffer. Okay, so let's go ahead and make the vertex buffer. And actually, this is a good point to talk about how OpenGL, how we create things in OpenGL. So the way you do stuff in OpenGL is, first of all, you tell OpenGL you want to generate something. Once you've generated that item, OpenGL is going to give you a handle to that item, which is going to be an integer value. And that integer value is what we're going to use to then tell the graphics card that this is the thing I want to modify, or this is the thing I want to use. So let's make an integer value for our vertex buffer. Okay, and I'm going to call this the vertex buffer. So this is where all of our vertices are going to reside on the graphics card. Okay, and the integer is just the handle to the vertex buffer. So technically, we could call this the vertex buffer handle, and maybe I'll just call it handle. I'm going to call it handle just for clarification that this is not actually the vertex buffer. This is a handle to the vertex buffer on the graphics card. And so the first thing in OpenGL, what you want to do is tell OpenGL we want to generate something. In this case, we want to generate a buffer. So we're going to tell OpenGL our vertex handle is going to be equal to GL gen buffer. Remember, this is the pattern we're going to pretty much follow for everything that we create on the graphics card. So first we generate the buffer. Next, we want to bind the buffer. So the buffer target, we're going to tell OpenGL what kind of buffer this is. Okay, so an array buffer, that's the first one there. Array buffer is what we want. That's an array of vertices. This can be an array of our vertices. And then it wants the handle to the buffer. Okay, so we're just going to give it the vertex buffer handle. Okay, and then from there, we want to actually pass the data to the graphics card. So with these two functions, we generated the vertex buffer, we bound the vertex buffer, which means, okay, we're now working on this vertex buffer. Then the next thing we do is actually send this data to the graphics card. And we do that through a function called buffer data. Again, we need to tell the target, that's an array buffer. The size, this is going to be the size of the data in bytes. We need to figure out how big all this is in bytes. And so we do that. So we're going to count the length of the array and multiply it by the size of floating point value. Okay, and that'll give us the size of this array in bytes. Next, it wants the actual data. So let's give it the vertices. And then finally, the usage. There's different types of usage. The static ones mean that the data we're passing in is not going to be modified. It's not going to change very much. The stream ones, or the dynamic ones, means that this data is probably going to change a lot. Okay, and the stream ones are the one is when you're going to change the data a lot, like every frame, you probably want to use the stream version. In our case, we're not going to change the data at all. We're just going to send it in one time, and it's going to just exist like that on the graphics card. So I'm going to use a static draw. Okay, and then finally, I want to unbind the buffer. So I'm going to tell bind buffer, the array buffer, that we're going to bind it to 0. Okay, and anytime you bind something to 0 in OpenGL, you're saying don't bind anything. Okay, nothing is bound. So if I bind buffer 0, that means there is no buffer bound. Now, technically, we don't have to unbind it. If we were to not make this call, it probably wouldn't even matter, is my guess. You probably don't have to unbind it like this. It's just, for me, easier to, I guess, picture what I'm doing when I do that. Next time you bind something, it would automatically be bound, and the previous thing would be unbound by necessity. So this is probably not necessary, but I'm going to do it just because it helps me out a little bit. Okay, so now we have the data on the graphics card. The next thing we're going to do is actually create the vertex and pixel shaders. Okay, so these vertex and pixel shaders, and actually they're actually called fragment shaders. So the pixel shader is called fragment shader in OpenGL. I'm just so used to calling everything a pixel shader that I'm probably going to call it pixel shader from here on out. But the pixel shader and the fragment shader are the same thing. Okay, so in OpenGL, they just call it a fragment shader. I'm probably going to call it a pixel shader, but you can call it either one of those two things, and everybody should know what you're talking about. But the vertex shader and the pixel shader are two programs that tell OpenGL how we want to transform each vertex and then how we want to display every pixel. Okay, what color do we want every pixel? So we have control over every vertex, and we have control over the color of every pixel. And that's really the power of the programmable pipeline. So let's go ahead and program the vertex and pixel shaders. So first of all, we need to make the code for the vertex shader. And I'm just going to make the code right here. I'm going to make a formatted string that is going to be my vertex shader code. So let's call this I'm going to call this the vertex shader code, and this is going to be a formatted string. Now, when you're programming your own vertex and pixel shaders, it doesn't have to be like this. You can actually put it in another file, but the important thing is you want to be able to get the code from that file and into your code as a string somehow. The functions that OpenGL uses, it operates on strings. Okay, so if you can get that source code into a string, then we can actually compile it in our program. But I'm going to put it right here inside my code just for simplicity. Our vertex and pixel shaders in OpenGL are actually written in GL.SL, and that's OpenGL Shader Language. I think that's what it stands for, OpenGL Shader Language. So it's GL.SL. I'm not going to get too heavy into everything about GL.SL. It looks very similar to C or C#. Every program opens with a main function. Okay, and inside this main function is where we define what's going to happen to every vertex. But before we can operate on a vertex, we actually have to pass the vertex data in somehow, or we have to get a variable that represents the vertex data. And actually, before I do that, there is one more thing I think that every GL.SL program needs. We need to define what version we're using. Okay, so at the very top of our code, you need to type hashtag version, then you type the version we're using. In our case, we're going to use 330. Okay, and what that stands for is version 3.30. As far as I'm aware, 3.30 is kind of the minimum you want to go for modern OpenGL. If you look at this, I think version 3.3 kind of is contemporary with Shader Model 4 with DirectX. So it's that kind of time period. And graphics cards using this shader model came out 2007 or 2008, somewhere in that period. And then finally, we type in core. Core means we're using the absolute newest version of OpenGL, and we don't want access to any of the old functions. Okay, the next thing we're going to do is actually pass in the vertex data. And so we use the in keyword, meaning that this is something coming into the shader. It's going to be a vector3, and a vector3 in GLSL is called vec3, so VEC3. These are all keywords. So in is a keyword, vec3 is a keyword, and then we give it a name. So I'm going to call this a position. This, we're passing in a vector3 that is our position. So every position we pass in is going to be a vector3. And that is everything we need for our current vertex shader as far as what we're passing in. Now, in the future, we're probably going to pass in other things. We might want to pass in a color. So I could put a vector4 here and put a color. All right, and that would just indicate that our vertex has a position and it also has a color. And the position is a vector3 and the color is a vector4. Ours is going to be more simple than that. We're just going to pass in a position only. As you can see up here, all we defined in our vertex data was position. We did not define color. So that's all we're going to do is position. And then what we need to do is now pass out the information in our main function. Okay, and the way we do that is by using a keyword. I think this is a keyword anyways, but there's or it's some kind of variable or keyword that OpenGL recognizes, and it's called GL position, and it has to be written just like that. As far as I'm aware, it has to be written just like this. And when you define GL position, GL.SL or the vertex shader understands that this is the final transformed vertex that we want to use for display. Okay, so whatever we assign to this is what OpenGL or GL.SL vertex shader is going to use to pass out then to the rest of the stages. Okay, so the position has to be a vector4, so we're going to set it to a vector4. We're just going to pass on through the position that we got. Whatever position we passed in, which is a position, we're just going to pass it on through to the GL position. Now, the position that we took in is a vector3, and we need to pass out a vector4. So I'm going to pass in a position, and then I'm going to set the W component to 1. So there we go. That is the very basic vertex shader code to get so we can draw our triangle. Next, we need to make the pixel shader code, and this is also could be called the fragment shader. Okay, now the fragment shader, you have to start the same way. We need to define the version that we're using. So this is going to be version 330, and it's also going to be the core profile. Again, the actual shader code itself is going to be defined inside the main function. And what the pixel shader does now is it actually defines what every color is going to be for every pixel. So in here, we're going to tell it, what color do I want every pixel to be? And the way I do that is by passing out a vector 4. So it's expecting a vector 4 to come out that defines the pixel color. And so what we do is we use the out keyword, say I'm going to pass out a vector 4 that is our color. And I could call this the result color or something like that, or the pixel color. Let's just call it the pixel color. And then inside the main function, I just set the pixel color to whatever I want the pixel color to be. And whatever I set this to, this is going to be passed out as the color that we're going to see on the screen. So let's make this a vector 4, so vec4. And you know what, let's just pick, I'm probably going to make this kind of a light yellow color. So let's do, so red will be 8, green will be 8, blue can be 1.1, not 8, it's going to be 0.8, 0.8, then 0.1 for the blue. And then the alpha is the last one. We'll just make that 1, so full alpha. If you look at this, so the first one is the red component, the second one is the green component, the third one's the blue, and then the last one is the alpha component. And so all I'm saying here with this simple program is I want every pixel that I'm passing out to be this color. So every time I use this shader, everything I draw is just going to be this color. So it's going to be very simple. And so now we have the source code for our vertex and pixel shaders. Let's go ahead. We need to now tell OpenGL that we want to generate some pixel shaders or create some pixel shaders. So we're going to create the pixel shaders. We're going to compile the pixel shaders. And so let's go to that point and then we'll talk about the next part. So tell OpenGL that we want to create a shader. The shader type, this one's going to be a vertex shader. And we tell OpenGL we want to, so once I create the shader, I actually need to get the handle to the shader. So let's make a handle over here for that. So I'm going to call this the vertex shader handle. And you'll notice I'm not defining this vertex shader handle outside of the class or outside of this function in the class, because eventually I'm just going to get rid of this resource. Okay, I'm just creating it right here so then I can use it in this function, and then I'm going to get rid of it almost immediately. And same thing with the pixel shader, because we're going to combine these into one program that we're going to use to draw all of our triangles. So now that we have that, we need to tell OpenGL what is the source code for this vertex shader. So we're going to do the shader source code. This tells OpenGL, here's what our shader source code looks like. So we need to pass in a handle to the shader. So this will be our vertex shader handle. It wants a string that is the code, okay? And so that's just going to be our vertex shader code. Once we've generated the shader, we told OpenGL, here is the source code. We need to go ahead and compile the shader. So I think there's a, compile shader code. And then we just pass in the vertex shader handle. All right, and that's it for compiling our shader. That should do our vertex shader. We're going to do the same thing for the pixel shader. So I'm just going to do this real quick. It's going to be the exact same thing, except for the type here is going to be a fragment shader. So in OpenGL, they call the pixel shader, they call it the fragment shader. Let's just do the same thing for the rest of this. We're going to set the source. This will be the pixel shader handle, and then the pixel shader code. And finally, let's just compile that pixel shader. That's it for our shaders. The very last step, we need to combine this into one shader program. So we're going to take the vertex shader, the pixel shader, and attach it to one single entity that's called a shader program in OpenGL. And in order to do that, I'm going to come up to the top and I'm going to make a handle to the shader program. So let's call this a shader program handle. All right, down here, again, we're going to follow the same pattern. We're going to tell OpenGL that we want to create a program. And let's set our program. See, this is our shader program handle will be equal to that. Okay, so now that we have a shader program, we actually have a shader program that OpenGL has given us for a resource. We're going to attach our vertex shader and our pixel shader to our program. So that'll just be GL attach shader, and So we're going to use the shader program handle, and let's just give it the handle for our vertex shader, and do the same thing for the pixel shader. Okay, so now that the pixel shader and the vertex shader are attached to our program, we're going to link them together. So let's tell OpenGL we want to link the program, and then just pass in the program handle. Okay, so now that we have our completed program, I can get rid of these individual shader resources. So down here, I'm going to tell OpenGL that I want to detach our shaders from the program. So let me go ahead and do that. So our shader program handle, let's detach the vertex shader. And then same thing for the pixel shader. Okay, and the reason I'm doing that is because I want to dispose of these resources. Okay, I don't need the pixel and vertex shader resources in memory anymore, so I'm going to get rid of them. So after we've detached them, we're going to delete the shader and just pass in the handle of the shader you want to delete. So the vertex shader handle, and then finally the pixel shader handle. Okay. So let's go down to our OnLoad function. Before I start drawing, I want to get rid, or I want to free the resources when the application. So when the application ends, I want to free the OpenGL resources that we've created. And those are the ones I defined up here. So we have our vertex buffer and we have our shader program. I want to free those resources at the end. So I'm going to tell OpenGL that I want to bind a buffer. Okay, and this is going to be an array buffer because this is our vertex buffer. I'm going to bind 0 to make sure that nothing is bound. And I'm not sure if this step is technically necessary. It may not be, but okay, so I'm just telling it that to make sure nothing is bound as a vertex buffer. And then let's delete the buffer, which is our vertex buffer. So that'll just be our vertex buffer handle. Then I'm going to do the same thing for the program. So we're going to tell OpenGL use program 0, which means that we're not using anything. We're making sure there's no bound programs. And then we're going to delete program and just pass in the handle for our program. Okay, and then that'll free all of the resources for us. Again, I'm not sure if this first part where I use program 0 or bind buffer 0 is technically necessary, but I'm just going to put it in there for now, and then I can do some further research on that later. Okay, so now we have most everything we need. Let's go ahead and go down to our draw code. Here we're clearing and we're presenting the back buffer. We're swapping buffers. In between those 2 points, we're going to tell OpenGL that we want to use program, and we're going to pass in the handle to our shader program. And then we're going to tell OpenGL that we want to draw arrays. Okay, and draw arrays is the actual draw function. This is the draw call to the graphics card. And so first of all, we need to tell it the primitive type. This is going to be triangles, and triangles just means that every 3 vertices defines 1 triangle. The next argument is the first index into the array. We're just going to start at the beginning, so we're going to make that 0. And the count is the number of vertices. Okay, so we're drawing 1 triangle, so we're just going to draw 3 vertices. So from there, we're almost done. We just have one more big thing to talk about, and that's vertex array objects. When you're programming an OpenGL core profile, I think vertex array objects are mandatory. You have to use them. But before I do that, let's talk about basically what's going to happen here. So the first thing we do is we use the program. So this is saying, here's our shader we're going to use. Now we need to tell it, where are the vertices we want to draw? We tell OpenGL which vertices we're going to use to draw by binding a vertex buffer. And we're going to give it the handle of the vertex buffer. And then the last thing, we need to tell OpenGL or the shader that's going to be taking the vertices, what format are these vertices in? We have 3 floating point values, and they define an X, a Y, and a Z, or they define a position. We have a function called VertexAttribPointer. We tell it the index of the vertex attribute, okay? And let's talk about what this is. So this is the index that OpenGL can find this attribute in the shader code. In our shader code, we actually didn't define the index yet. So technically, we could go back and we can tell OpenGL to look up, where is this, or what is the index to this? Tell me what the index to this A position is, so then I can use it later. But instead of doing that, I'm going to do something called, I'm going to put a little something in front of this, and it's called layout location equals and 0. And so when I put this in front of this attribute, I'm saying that this is the index that I want this position to be located at. So this is how I'm going to reference this position. value, okay, or this position vertex attribute. Okay, so this is going to be index 0. If I had another vertex attribute, I could do that by saying layout location equals 1, and this could be a vector 4 that was a color. Okay, so then I'm saying the vertex attribute that is a color is at index 1. Okay, and we can just keep doing that for as many attributes as we need. But let's get rid of that because we're just going to have the one attribute, which is at index 0. Okay, so down here, I'm telling the vertex attribute pointer that index 0, I'm defining what index 0 is, what it looks like. The size is how many elements it has. Okay, so this is a vector 3, so it has an x, a y, and a z, so it's going to have 3 elements. The type, they're going to be floating point types. Okay, so these are all floating points. Normalized is something I'm not going to get into. I would have to do a little bit more research to see what that means, or maybe somebody can write in the comments if they know, if they have a better idea of what this normalized means. But for me, it's always been false right now, and we'll do some research and find out what that actually means. The stride, so this is how many bytes exist in the vertex buffer between each vertex. And for us, we have 3 floating point values, which are the x, y, and z. And so all we have to do is tell it that we need to advance by 3 times the size of a floating point. And then finally, the offset, that's where do we want to start? We just want to start at the beginning, and then we are done with that. And then finally, we need to tell OpenGL that we want to enable this vertex attribute array, and that'll be at index 0. Okay, and you can see this 0 index matches this 0 index because I'm just saying I want to enable this attribute. All right, so we are pretty much there. If I run this, it's actually not going to draw anything because I'm missing one crucial component. And that component is called the vertex array object. So I'm going to go to the top here. I'm going to make something called a, this is going to be a handle to a vertex array. I'm going to call this vertex array handle. And the vertex array handle, or the vertex array object, let me scroll down here to this on render frame, basically encapsulates all of this information and allows us to just bind it all at once. Okay, so I don't have to do this every time. I could just bind the vertex array object and it will do all of this stuff every time. So I'm going to cut this out of here. I'm going to go back up to our OnLoad function. After we've bound or sent our vertex data to the graphics card, I'm going to create or generate the vertex array handle. Okay, so GL, we're going to gen vertex array. Then we need to bind the, bind the vertex array and pass it in the handle to the vertex array. Once I've bound the vertex array, and I'm going to paste this code right in here. So this is the same code that I had down in our draw code earlier. All of this stuff will then be bound to the vertex array object. Okay, so once I bind the vertex array here, everything I write after that is going to be bound to that vertex array. It's almost like, and it's probably not like this in reality, but this is the way my mind sees it. It's almost like everything I write after binding the vertex array is what's going to happen when I use that vertex array again. And then finally, I'm going to unbind the vertex array. And the way we do that is by simply passing in 0. Okay, so that is pretty much it. Again, the vertex array is mandatory. Okay, so there we go. We have the, so we've specified the vertex array information. So from there, I can go down to the draw code, and instead of specifying all of this every time I want to draw, all I have to do is now bind the vertex array before I draw. Okay, so let's go down here. We're in the render frame. First thing we're doing is we are clearing the screen. We're telling it which shader program we want to use. Then we have to bind our vertex array. I'll just pass in the vertex array handle, and then we draw our arrays. Let's go ahead and run that and see how it looks. All right, so there we are. That is our first triangle in OpenGL. It seems like there's a lot to it, but once you have that, I'm hopeful that the rest of this will just be very incremental steps. So the vertex arrays are probably the most interesting thing to me, or the thing that took me just a little bit longer to comprehend. But they're absolutely necessary for programming an OpenGL core profile. And again, the vertex array is where you basically describe everything that the computer needs to understand the data. So first of all, the computer needs, or the graphics card needs to know what the actual data is, and that's the vertex buffer. Then it needs to know what each vertex looks like. All right, so let's go ahead and run that one more time. So that is how to draw your first triangle in OpenGL.